Hello, this is question 9 on June 2018 paper. It's a mechanics year 2 question of chapter 7. It's application of forces, and these questions can be sometimes a bit not complicated but complex. So I'm going to show you how you can get full marks on it. So you have a plank AB, is this one here, and the mass is M, the length is 2A, is resting with its end A against a rough vertical wall, so we have friction here. Plank is held in a horizontal position by a rope, which is this one. We know this angle. They say small block of mass 3m is placed on the plank at the point P, so we have a block here, and AP is x, some distance. Plank is in equilibrium, and we know the angle, and the plank is modeled as an uniform rod. So this is important because that means that the weight, it will be in the midpoint of the rod. The first thing they ask is, using the model, show that the tension in the rope is this one. So first of all, like all of these questions, is to draw all the forces that you have acting on the plank. So on the plank you have the own weight will be in the middle. Let's say this is the middle, is mg. Then you have this block, which is 3mg. Then you have normal reaction from the wall, pointing that way. I'm going to call it, let's say, R. You have friction, this one. It's not moving, but you know that if you didn't have friction and this is super slippery, this plank will slip down. Yeah, so the friction go against that tendency of motion. And the last thing that you have is the tension in the rope. So you have a tension here, and I'm going to call it T. So these are all the forces. I need to find the tension. Tension is here. It's in equilibrium, and every time I have an object in equilibrium, I can apply a sum of forces 0 in any direction, of moment about any point 0. You will have to think a tiny bit what is more convenient, because you can do these questions in more than one way, but if you think a minute what would be more convenient, that question can be much simpler. So I would say we need to find tension, and we don't know this friction or this normal reaction. So if we take moments about A, we won't have these two forces in our equation because they pass through the point, but we will have tension. That would be ideal. So let's going to do that. We're going to have space, so I'm going to do in the next page. I'm going to take moments about A for the first part. So for A, I'm going to take moments about A, and that must be 0. So these two are producing clockwise moment about A. This one is producing anti-clockwise moment. So the two clockwise will be the same as anti-clockwise. So mg times this distance, which is A. So is the force times the distance, plus the other force is 3mg, and the distance was x. Yeah, distance from A to the block is x, so times x is going to be the tension times by the distance. But remember, this is the perpendicular distance from the point to the line of the force. So this is the line of the force, line of T, and this is perpendicular. So we are talking about this distance here. That's what we need to find. This distance here, this is 2A, and this is the opposite to the angle. So this is going to be 2A sine of alpha. Sine because it's the opposite. So this length here is going to be 2A sine of alpha. But we know tan of alpha. You know what, when tan of alpha is 3/4, you can use that wonderful triangle, which is this is alpha, opposite is 3, adjacent is 4, with Pythagoras this is 5, so sine of alpha is 3/5, so this is going to be 2a times 3/5 or 6a over 5, and that will help a lot. So I carry on with my equation. So it's t times, what did I say, 6a divided by 5. Yeah, and from here I just kind of make t the subject, and then I will get for sure what I had to prove. Yeah, so 5mg is just making t the subject, mg a plus 3x divided by 6a. Yeah, So this is the first thing. And you are going to get 1 mark for applying moments about, so for method, 1 mark for getting the equation correct, and 1 mark to getting the proper answer, even if it's given, right? For B, they tell me magnitude of the horizontal component of the force exerted on the plank at A by the wall is 2 mg. So this is the normal reaction, is 2 mg. So they are giving me this value here. This is 2 mg. They say find x in terms of A. So now we know one horizontal force, we have applied moment, so one other option that we can use is to resolve horizontally. And horizontally we have one force pointing that way and the component of this force pointing that way. So remember, if we resolve forces, this tension will have two components, one vertical and one horizontal. The horizontal pointing that way is going to be T cos of alpha, and the vertical is going to be T sine of alpha. So that means that if I resolve horizontally, this 2 mg is going to be T cos of alpha. So I have that if I resolve horizontally, I have that 2 mg pointing right is going to be T cos of alpha pointing left. So 2 mg is going to be T. I have a whole expression for T in terms of A and X, and I need X in my equation because that's precisely what they asked me, divided by 6A, and cos of alpha from here is 4/5, so times 4/5. I can start to simplify things and I can make X the subject, so solve for X, and I get that X is 2/3 of A. Just making X the subject or solving for A in terms of A. So this one, you have 1 mark for the method, so for resolving horizontally. Let me see how many marks you have. 2 marks, and 1 for your final answer. So 2 marks. Yeah. More. So for C, they say the force exerted on the plank at A by the wall acts in a direction which makes an angle beta with the horizontal. What is this force? Because they have already talked about this force before. So they say the magnitude of the horizontal component of the force is 2 mg. And now they talk about the force itself. So that means that let me clean this. I have a normal reaction that I know and a friction, but these two forces combined, they are going to give me my force on the wall. So this is the force on the wall. I'm going to call it, let's say, F. Yeah, this one is given, and what they are asking me now is the angle of this force with the horizontal, which is beta. That's what they say. Find the value of tan of beta, when beta is the angle with the horizontal. So I know this component. If I am able to know this component, I can find tan of beta because it's opposite divided by adjacent. How can I find this vertical one? So I would say resolving vertically, because I haven't used that equation yet, and I have 2 forces down and 2 forces up. So I'm going to do that, resolve vertically. So for C, I'm going to resolve vertically, and my 2 forces up, which are the friction plus the component of the tension. The component of the tension is going to be T sine of alpha, and sine of alpha was 3/5. T sine of alpha, so 3/5 times 3/5 is going to be the 2 forces pointing down that are the weight of the bar or the plank plus the weight of the block that you have. Yeah. Tension is this one. But I know what the value of X is now, so I can find the tension, and the tension is going to be 5 mg, and then I have A plus 2/3 of A times by 3 is 2A, so this all together will be 3A, divided by 6A, I just have 2. Yeah, I can simplify. So this is my tension, and if I substitute the tension here and I find the friction, I'm not going to waste time doing that because you are faster than me, surely. So this is 5 mg divided by 2. That's my friction. So now I have my two components. So I have my friction pointing up, which is 5 mg divided by 2. And to the right, I have 2 mg. And I need to find this angle here, which is beta. So tan of beta is going to be opposite, which is 5 mg divided by 2 divided by adjacent, which is 2 mg. So this is 5 quarters. And they don't ask me the angle, they ask me tan. So you don't need to do tan minus 1. So tan of beta is 5 marks. Tan of beta is 5 marks. It's 5/4, sorry. The marks here, you have 1 mark for resolving vertically, 1 mark for finding the correct equation. How many marks we have? 5 marks. 1 is to find this correctly and substitute. This one for finding the friction, and this one for the answer. So 5 marks. Just if you want to get full marks, don't skip steps. So leave all the steps clear, because it's the way of getting the working out marks. And then last bit, they say the rope will break if the tension exceeds 5 mg. We have an expression for the tension, right? Remember that. Explain how it will restrict the possible position of P. So we have to think where this P can be. So at one point, if P goes too close or too far, this tension will be too much and the string will break. So let's go to see that. The tension, in terms of x again, so I'm not going to use this tension here, and I'm going to use in terms of x, needs to be smaller than, so the tension was 5 mg a plus 3x, sorry, divided by 6a, that must be smaller or equal, well, actually smaller, because when it's equal, will break, 5 mg. So this one is really smaller, so we don't want it to break. Smaller than, what did I say? I forgot. 5 mg. 5 mg, smaller than 5 mg. And we just resolve for x. So if we resolve our equation, this one will be x, will be 5a divided by 3. This is 3 marks. 1 is for writing the correct inequality. Second one is for solving it, and the next one is for your conclusion. So you have to say a line, something like the string will break, the string will break if the block is farther, for example. So x must be smaller than 5a over 3. So if it's farther than that, it will if it's farther, if it's farther than 5a over 3 from a, or something like that. You can say, or if x is greater than 5a over 3, something like that. But you have to give a line or conclusion explaining what do you mean by this. Yeah, it's not enough if it's 3 marks. If it's just 2 marks, it would be enough. Yep. So this is all with this question. Hello, if you liked the video, I have a free last-minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well, because the questions are identical, you just have less topics. I have other courses through the year, they are all in my website, and the link is as well in the description below. I would love to help you.